Hi, this is Steve Williams with the Right Approach Consulting. This morning, I'm with John Bushy, Director of Technology for American Standard Circuits. Good morning, John.
Hi, Steve. How are you?
I'm well. How are you?
Very well.
So, what we're talking about today is material selection for RF microwave products, and you're one of ASC's experts. This falls with a lot of other things under your areas of expertise, and I'm sure you get a lot of questions from customers on material selection and what do I need and how does it fit my application. Talk a little bit about the kind of questions you got, and then some of the things that customers need to understand when they're selecting materials.
Steve, as you can imagine, there's a wide range of materials available nowadays. We have products available from what are considered the conventional type materials, which are fairly moderate loss materials. Those are your typical FR4s and what are now generally lead-free processable products, which are advanced epoxy systems, typically phenolic cured. And then we range to the ultra low loss, and these are materials that are designed to be utilized up into the upper gigahertz. And by that, I mean generally the millimeter wave and above. This is where you're approaching 30, 40 gigahertz up to one of the most widely used applications, which is vehicular collision avoidance, which would be 77 gigahertz.
Um,
Uh,
so when you talked earlier about loss, now somebody as simple as me is the lower the loss, the higher the speed.
Generally, yes, but the basic principle is that as frequencies increase, the interaction with the laminate material itself starts to increase, and it's this interaction that introduces the loss. There's also obviously conductor losses as frequency increases as well. So a general rule of thumb is that the higher the frequency, the lower the loss requirement of that particular material, or the lower the dissipation factor required. Which is why when we start talking about some of the higher frequency 77 gigahertz applications, dissipation factor can be, 10 times lower than it would be for a standard FR4 type material. That's one of the reasons those types of materials are not only so favored in RF applications, but it's also a reason why those materials tend to be fairly expensive. They have unique material properties. With the increased usage of conventional low loss thermosetting resin systems, and I call them conventional because they're not like the thermoplastics of PTFE materials, the PPO, PPEs, and the hydrocarbon materials, we're now starting to approach those loss levels. And so you see these more traditionally fabricated materials being utilized into frequency ranges, in the 10, 20 gigahertz range.
Okay. So when you get a new design for an RF microwave type product, you must spend a lot of time with the customer early on material selection and trying to match to the application.
Yeah, there's a lot of going back and forth because most often people select very low loss materials, or they know that their circuitry will generally function well with the highest performing materials available. Then you have to go through the set of trade-offs that presents. Number one being cost, and usually there's some compromises or can be in electrical performance. Again, that's a landscape that's changing a little bit, and that we see some of these thermosetting materials are now being utilized widespread in areas that have traditionally only been the domain of ultra low loss, ultra high Teflon content materials.
Okay, that makes a lot of sense. Is there anything that you've seen that's, I guess, relatively new offerings for this type of product?
No, not really. And the reason I say that is because these materials have been in developed for a long period of time. But what we see is the offerings from the number of suppliers has increased almost exponentially. It seems like almost every thermosetting laminate manufacturers now offering what we consider ultra low loss materials. And what that means is there's more variety. There's the ability to be able to fine tune the designs to a higher degree than in the past. Multi-layer structures can now become more complex as we begin to utilize low loss prepregs of a wide range of thicknesses and constructions to fine tune not only thickness but dielectric constant within a multi-layer structure. These are all just aiding in the complexity and higher integration of these assemblies. And what we also see is the combination of what used to be seen as a hybridization used to be represented by a single or two types of materials blended together in the same multi-layer structure. Now it's not uncommon to see three, four, and possibly more materials in the same structure, as each one is performing a slightly different task, and therefore it has different performance requirements, both from an electrical standpoint, in a lot of cases, a mechanical or a thermal standpoint.
So that must make your job even more difficult when you've got that kind of a hybrid and you've got to make sure that all these different material sets play nice together.
I think it lengthens the development process in some respects because there needs to be more active discussion and interaction during the design stage to make sure that you end up where you really need to be. As the designs get more complex, so does the design cycle, to be honest with you.
Okay. Okay. And that's something we want, right? I mean, you guys preach early supplier engagement with your customers, right? On just about everything.
It equals a higher level of success, or I mean, or I should say, a higher assurance of success. And what you find is that with a lot of communication, most issues are either dealt with up front, or if there are issues or risks that cannot be managed, we figure out different methods of being able to either design them out or we figure out some unique mitigation strategy so that even though you can't eliminate it entirely, you can figure out a way of either making the system work, even though the tolerance for a given feature may not be what you want or what would be desired.
Sure. Okay. Any final comments to your customers or potential customers, John, when it comes to this type of issue?
Is be open, engage, and this is nothing new, Steve. I mean,
Mhm.
we've preached it for a long time. And engage your fabricator as early as possible. If they offer these types of design sessions, please utilize them. Uh, Trust that most fabricators have your your ideals or goals in mind, and they're all trying to work towards the same end, which is success. And so therefore we try to work with our customers and give them as much useful information as possible. And generally when we say something's going to present issues, we mean it seriously. And again, we want to make sure we don't end up in a situation with a beautiful design that can be very difficult to manufacture for one or two particular aspects.
Excellent. Excellent. I mean, American Standard Circuits, one of the things that differentiates you guys is your amount of engineering support to your customers. And, John is one of the experts there. People can get a hold of you through the American Standard website if they've got questions, right?
Absolutely. They can either ask a technical question, and that will usually find its way to the correct individual, or a lot of us are available by phone. We're not beyond picking up the phone and answering direct technical questions, but again, email is a very convenient method.
Excellent. Excellent. And, I'd be remiss if I didn't mention this. The stuff we've been talking about. I mean, people say all the time, "Oh, this guy wrote the book on this," but you actually did write the book on this, right? You got an RF microwave book out that you co-wrote with an A. Vardia at American Standard Circuits, and people can get that through your website as well.
Yes, it's available in electronic format, and if you're old school and you want a hardbound, I'm sure we can get a copy of those as well.
Outstanding. Well, John, I appreciate your time this morning.
My pleasure, Steve.
Very good. Once again, Steve Williams with John Bushy at American Standard Circuits, and thanks for listening.